Welcome to Tricked Out. I'm Andrew Totolis. On this show, we take some of the coolest modifications in the sport compact world and show you what it takes to do it yourself. Today, we're working with a 1992 Honda Civic. The 5th generation Civic hatchback is one of the most popular amongst the tuner crowd because it's lightweight and it is infinitely moddable. And this particular ride has already seen some changes, but the owner wants to squeeze some more power out of this B18 Integra engine. So I'm going to help him out by optimizing his valve timing with a set of high-performance camshafts and adjustable cam gears. On a scale of 1 to 5, today's project rates a 4 on our intermediate scale. All the parts are bolt-on, but we need to disassemble the top of the engine, so it's going to take some clear thought and patience. If you're cool with that, you should have no problem with today's project. Now, before we get started, let's take a closer look at the project car.
This Honda Civic belongs to Sean Pepper. Sean's 5th gen Civic is all about performance, so he's nixed a flashy paint job for traditional hot rod flat black. JDM turn signals, diamond clear HID headlights with city lights, and JDM SI tails update the factory look. And Sean rides tight on a lowered suspension with 93 Integra GSR wheels and 4-wheel Integra discs. Inside, Integra GSR seats and a JDM center console work with an aftermarket steering wheel to update the look. And an upgraded head unit with a low-profile custom sub-box pumps solid-sounding tunes without drawing unwanted attention. Under the hood, things get interesting with a B18B Integra motor swap sporting a cold air intake, and spent gases exit out through the wrapped racing headers and out the stainless steel exhaust. This is a fine ride indeed, but no car is truly complete until it's been tricked out.
Man, that's an ominous-looking ride. Here's what you're going to need for today's project.
Start off with a high-quality set of billet ground camshafts and a set of adjustable cam gears. Plus, a set of high-performance valve springs with retainers and locks. You'll want a valve cover gasket kit and fresh camshaft seals, plus a valve spring compressor and a compression tester. High-temp RTV silicone and assembly lube are also needed, along with a floor jack, jack stands, and wheel chocks to keep things safe. Plus, a cutoff saw and your standard shop tools to get it all done.
You can get a complete list of materials and instructions by visiting our website at DIYnetwork.com. On this show, we're always talking about how to get more air and fuel into the cylinder for more power. And that usually comes in the form of a cold air intake or a free-flowing exhaust. If you already have these on your car and you want more power, join the club. No, really, it can happen, but you have to talk to your valves. Now, your valves aren't going to listen to you, but they will listen to the camshaft. The camshaft's job is to determine how long and wide the valves stay open. Like our project car, this is a dual overhead cam engine. Isn't it beautiful? It's got one cam for the intake valves and one for the exhaust valves. All right, we're about to go to school here. Get your number 2 pencils out. This is the timing belt. It goes around these cam sprockets, which keeps the valves in time with the crankshaft. All right, hold on. Yeah, I must really love you guys if I'm doing this, right? As the camshaft turns, the lobes push against the rocker arms, which operate the valves. I'm going to show you. Check this out. I love getting dirty. All right. Keep your eye. Pretty cool, right? Now, as you can see, there are 8 lobes on each camshaft. Now, if we change the size or orientation of the lobes, it's going to change the way the valves operate. So depending on what you want to do, you can get a cam for higher RPMs for more speed or a cam for more lower-end torque. Now, our cam swap's going to be great because it's going to open our valves longer and wider, but it's going to keep the same timing for a street-friendly car. Let's do it.
Every car is different, but most sport compacts are dual overhead cam engines, and getting the prep work done is pretty similar. In a stock car, you're going to have to remove the accessory belts to remove these covers. But like most engine-swapped rides, our project car already has them removed for easy tuning access. Start by disconnecting the negative battery terminal. Then, pull up the spark plug wires and remove the spark plugs to allow the engine to spin freely. Next, pull off the crankcase ventilation hose. Then, remove the valve cover bolts and pull the valve cover up and off. Anything that gets dropped down into the plug holes can be a pain to remove if you see it go in, and disastrous if you don't. So stuff some rags down into the holes to keep everything clean inside. Before you remove the timing belt, you'll have to rotate your engine to top dead center. On the Civic, you'll have to jack the car up and reach in through the driver's wheel well to turn the crankshaft. Since this is a running engine, we can check the marks on the camshafts to verify top dead center.
Next, we're going to remove the distributor. Now, I've marked the position so when I reinstall it, it doesn't affect the ignition timing.
Next, remove the bolts that hold the distributor on. Unplug the wiring harnesses at the back and pull the distributor out of the head.
All right, now that I have the distributor off, here's a couple of quick tips. I like to leave the plug wires on in the position that I found them. This way, it's one less thing I have to keep in my brain. Also, don't spin this distributor shaft. It's gonna make it a lot easier to reinstall later. All right, after the break, camshafts are coming out, baby. Fast cars, even faster. If you're just tuning in, today I'm adding a set of high-performance adjustable cams to a 92 Honda Civic with an Integra engine stuffed under the hood. I've already set the engine to top dead center, removed the distributor and the valve cover, so now we can see the cams. And guess what? They're coming out. Our next step is to loosen the tensioner on the timing belt so we can slide the belt over the cam gears.
The timing belt tensioner is down on the front of the engine. You'll have to loosen the locking bolt in the center to loosen the belt. After the tensioner is released, you can slide the timing belt off of the cam gears and remove the cams. Loosen the cam caps by working in a cross pattern from the middle out. All of the valve train parts, including the bolts, need to be replaced in the exact position they were removed from. So loosen the bolts until they're free to come out, but leave them in the caps so you can keep the matching parts together. When all of the cam cap bolts are free, use a rubber mallet to lightly tap them loose. Then, stick them into a piece of cardboard to keep their order outside of the car. Once all of the cam caps are removed and laid out nicely on the cardboard, you can lift the camshaft out and repeat the process for the other side.
The taller and thicker lobes will open the valves longer and wider, allowing more air-fuel mixture into the cylinder. Now, this is great. But since our valves are going to be working faster than before, we need to upgrade the springs as well. So I picked up some stiffer springs with titanium retainers and steel locks. This is going to rule, because stiffer springs and less weight in the valve train means we can run the engine at higher RPMs for a longer amount of time without doing any damage. Let's get back in here for a second. These are the rocker arms. They're the contact point between the lobes and the valve. The lobe rolls around, pushes on the rocker arm, and it opens the valve. They pop right out, really simple. But keep them over here on your cam board because these have to go back in the same order that they came out. All right, next thing are the springs. These have to come out as well. You need a spring compressor to do the job. You can pick up one of these at your local auto center for about 15 bucks. Now, my only beef with these is that they're made for working on honking V8s, not a dual overhead cam Honda engine. So they have these ears right here that get in the way. Easily solved. Grind them off, and you're ready to flow. Or you can pick up the proper tool to do the job. Costs about 5 times more than the other spring compressor, but it's gonna make the job easier and faster, and I'm a tool freak. I like to have the right stuff. All right, come back in here for a second. Follow me. See this right here? This is the valve. It lives in the middle of the spring. Now, once we take the spring out of there, gravity is gonna take that valve and drop it right into the cylinder. So, short of turning the car upside down to do the job, we have to find a way to keep the valve in there. That's where this compression tester comes in. Now, everybody should have one of these. It's a great tool. You can pick it up also at your local auto center, but we don't need the whole thing. We only need this piece right here. We're gonna use this to pressurize the cylinder to hold the valve in place underneath. All right, let's get to it.
Before you do anything, stuff some paper towels into the ports in the head to keep any stray parts from falling down into the engine. Then, remove the rag from the first plug hole and screw in the plug adapter. Hook up the air to the tool to pressurize the cylinder, and then bolt the valve spring compressor to the end cap mounts on either side of the head. Use the pivot arm to release pressure on the valve spring locks. Then, remove the locks from the top of the first spring with a magnet and pull out the old spring. Next, combine the locks into the retainer and add the retainer and the locks together with the new spring onto the valve stem. Compress the assembly with a compressor and work the locks into place carefully with a pick tool. It's a delicate procedure, but you'll get the hang of it if you just take your time. Repeat the process for the other 3 valves on the first cylinder, then move the plug adapter to the next cylinder and replace all the springs down the line. Replacing the 16 springs on a B18 Honda head isn't that difficult, but it is time-consuming. So So make sure to plan for a couple of hours on this part of the project. Your engine is counting on you.
When you get all the springs swapped out, drop a little dab of assembly lube on the top of all the valve stems. Then we can start putting the engine back together again. We're going to start with the rocker arms. Now, when you're putting these back in, give them a little inspection, make sure there's no wear on them that they might score the new cams. I'm going to finish this up, and we're going to see you back here in a few. I'm Andrew Totolis. On this show, we take sport compact cars and turn them into lean, mean, fighting machines. Today, I'm installing a set of high-performance adjustable cams into a Honda Civic hatchback. I've already removed the old cams and put in a fresh new set of valve springs, and the new cams are almost ready to go back in. But before I do that, I'm going to throw on some adjustable cam gears. Now, adjustable gears, in theory, are pretty simple. Even though our new cams are going to open our valves wider and longer, they're still locked into a certain time via the timing belt. With adjustable gears, we can tweak each cam individually to maximize the power curve of the engine. The next thing to do is to remove the old gear and retrieve the key.
Wrap the new cam in a towel for protection and then lock it into a vise. Then, remove the factory securing bolt, wiggle the cam gear loose, and retrieve the key. Swap the new cam into the vise. Then, apply a light coating of assembly lube to the cam seal. Place the cam seal on the cam, then set the key in place and slide the gear onto the end of the shaft. Apply some light oil to the cam gear bolt before installing it, and torque the bolts down to 25 foot-pounds on each cam. When you're finished, adjust the cam gear so that their timing marks are set to 0, and tighten all 5 of the adjustment bolts to 15 foot-pounds each. Then, take the cams to the engine for the install. Before you install the cams, apply a liberal coat of assembly lube to help break in the parts gently.
When you put the cams back in, remember, there's 2 different kinds. Don't mix them up. There's an intake and an exhaust. The intake, remember, is the slotted one that fits into the distributor.
As you replace the cams, be sure to check the timing marks on the new cam gears. You'll want them to align in the center just like the original set. Once the intake cam is in place, you can drop in the exhaust cam. Now, since the exhaust cam doesn't have a distributor on its end, you can replace the factory rubber end cap or pop in an upgraded billet aluminum cap for a trick look and an improved seal. When they're both in place, double-check the seals and then make a run with the assembly lube on the cams. Replace the cam caps carefully back in their original positions and hand tighten the bolts as you go. Next, apply a thin bead of gasket sealer to the outer bearing caps where they contact the cylinder head. Then install the end caps hand tight. Make sure to install the larger 12mm bolts on the inside position and the smaller 10mm bolts on the outside. When all of the parts are in place, tighten all the cap bolts working from the inside out in stages. First, snug them up with a ratchet, then go back and torque them to 20 foot-pounds for the inside bolts and 7.2 foot-pounds for the outside.
These look awesome. The next thing we're going to do is put the timing belt back on. But before we do, we want to make sure the cams are at top dead center, which is easy because we have some reference marks to go by. We have some on top and some here on the side. Now, when you do this project, you'd want to put a new timing belt on. But since Sean, the owner's already swapped the engine out, he's got a new belt in here, so we're good to go.
Slide the belt onto the exhaust cam sprocket first. You might have to use a wrench to turn the cam a few degrees to top dead center, but once you get it started, the rest should be easy. Next, retension the belt by tightening the tensioner. Then, rotate the crankshaft counterclockwise for 6 complete revolutions. Return it to top dead center and check to make sure that your new camshaft sprockets are still aligned.
All right, the cams are in and the timing belt's back on, but we have one more thing to do before we take this hot rod to the dyno.
I'll show you.
Tricked out. This is where we show you how to beef up your sport compact with some of the coolest mods around. Today, I'm prepping an already modified Honda Civic hatchback for a more useful power band with a set of high-performance cams. I've already installed a new set of valve springs and cams with some super trick adjustable cam gears and reinstalled the timing belt. Now, we're about to take this to the dyno for some real fine-tuning, but there's one more thing I want to talk about. This valve cover. Now, we could put this on as is, but as you can see, it's covering our adjustable cams, which kind of defeats the purpose of having adjustable cams if you can't get to them to adjust them. So we got some options here. First, we could do a laser moon cut, which looks amazing, but it's going to cost some coin. You could also borrow your buddy's already cut cover, put it on there, go to the dyno, do your tuning, put your valve cover back on, and there's some kind of secret what's under your valve cover. But By the look of my man's car, I don't think he's trying to hide anything. So, what are we gonna do? We're gonna do it ourselves, like everything else. I'm gonna cut this with a cut saw, and if you don't have a cut saw, you can use a rotary tool. Let's do it.
Mark a cut line across the top with painter's tape, then cut it off with a cutoff saw. When you're done, use a file or sandpaper to clean up the edges. Then clean the valve cover thoroughly to ensure that there are no metal shavings left inside. Next, lightly oil the gaskets to ensure a proper seal, then install them into the valve cover. Back at the car, remove the towels, then replace the valve cover on the engine and torque all of the bolts down to 7.2 foot-pounds. Once the valve cover is replaced, you can reinstall the spark plugs, the PCV hose, and the distributor. Line up the tab on the intake cam with the slot on the distributor. The tab and the slot are slightly off-center so that they will only fit together in the correct way. Finger tighten the 3 bolts, then match up the paint mark you made at the start of the project and tighten everything down. To finish things up, install the plug wires, plug in the distributor harness, reattach the negative battery cable, and drop the car to the ground.
Well, that completes the project. We've put the car back together again, and now it's time to get into some serious tuning. So you know what that means. To the dyno!
First up is a baseline run to establish where we're coming from. Without any further tuning, the new cams improve the horsepower curve above 6,000 RPM. Once the baseline is set, you can adjust the cams by loosening the cam gear adjustment bolts and turning the cam bolt while the timing belt holds the gear steady. On the B18 Honda engine, each time you adjust the intake cam timing, you'll need to reset the ignition timing because they're directly connected. After the timing is set, you can make another run. The logical progression is to try the intake at 0, plus and minus 2 degrees. Then do the same with the exhaust cam and also work any strong combinations. In the end, our best setup with this engine and cams turned out to be minus 2 degrees on the intake and 0 degrees on the exhaust. At this setting, the engine produced a respectable gain of about 17 horsepower. And instead of peaking at 5,600, the power curve continues all the way to 7,000 RPM.
Wow, you can really see the difference some well-designed parts can make. Let's run down the cost of today's project.
The camshafts cost about $600, and the valve spring kit adds in another $400. The adjustable cam gears were $230, and the seals and gaskets cost $45. We spent another $80 on the valve spring compressor and $15 on the compression tester. Plus, the sealants and lubricants added in another $10. The total cost for today's project is $1,380.
Hey, that's not too bad. And get this, by installing the parts ourselves, we saved almost $1,000. Yeah. Now, there's one more thing to do before we close up the shop today, and that's take a look at the results.
Before our mods, this black beauty had all the makings of a tough guy street machine. But the factory cams were locking up some usable power. With a little effort, we installed a set of high-performance street cams and bumped up the power curve in this Renegade ride. And you can bet that it's ready for whatever its owner, Sean, decides to throw its way.
Don't forget, you can get a complete list of materials and instructions for all the projects you see here on Tricked Out by visiting us at our website at DIYnetwork.com. Now go trick out your own ride. We'll see you next time.